exciting responses. Yes. Let's do this. All right, so today we're looking at rules for the nth term in a sequence modelling linear growth and decay. So previously we've been using recursion, which is when we've had to put all the VNs and all the N's in, and we have to show our working out for each one. That's really good if we're just trying to find something that's in a consecutive order, but if we want to find the nth term or a random term, such as the 45th term or the 63rd term, trying to go through that would take forever. So instead of doing that, we can use a rule, which will give us that term. So that's what goes in there. We can use, and it actually doesn't have a name, it's just called the rule. So it doesn't have a name. Okay, so this is our rule, and depending if we're increasing or decreasing, it will be a plus or a minus. If we're increasing, it's going to be a plus. If we're decreasing, it's going to be a minus. And same as what we talked about the other day, our VO is our starting value, and our D is our difference. So when we're asked to find a term that's not in a consecutive order, this is the rule we need to use. This is how we're going to find it. It's really important though when we're reading questions, if we are asked to write a rule in terms of n, we keep n in the formula. So you will quite often get asked, good morning, that's okay. Was there any spare sheets? Yep, cool. So if you will possibly get a question that will ask you to write a rule in terms of n. And if it says in terms of n, you need to make sure you have n in your formula and you don't sub in the number before you've written the rule. Does that make sense? When we go through an example, hopefully it will make sense. Because usually it will be talking about, you usually get two questions in one, and it will say, find the 45th term, but first write the rule in terms of n. So write the rule in terms of n. Once you've written the rule in terms of n, then you'll sub in the 45th term as n. So two different things. We'll go through some examples and that will make a bit more sense. Also really important that if we are doing a question that is recursion and it asks you to find like the, in the first 5 terms, you need to use recursion. If it asks you to find a term and it doesn't say anything about recursion, this is when you can use the rule. That was one thing that a lot of people lost marks on in the exam last year. If it was a question on recursion and then they were asked to find, I think they were asked to find the 5th term, and a lot of people just used this rule. Because the question was asking about recursion, you had to use recursion to get to the 5th term. So if you didn't use recursion and you use this and you still got the right answer, you didn't get the marks.
So recursion's what we did last lesson?
Yes, recursion is what we did last lesson.
So it won't say don't use recursion.
If it doesn't say anything about recursion, use this.
Okay.
Yeah. But if it says recursion, you must use recursion.
Would there be a chance that they don't say use recursion or you have to use recursion?
No, they will say. It will be pretty obvious that they're talking about recursion. Yeah. But if they're asking you to find like the 10th or 12th term or something, use the rule. They're not going to make you do recursion to find 12 terms in a row. All right, any questions so far? Cool. All right, let's go down a bit. So, couple of rules here. So, for simple interest, investments and loans, this is the formula we're going to use. Flat rate depreciation, that's going to have a V0 in front of it, in there. And unit cost depreciation. If we are given interest rates, okay, oops, I've got the I, that was weird. If given interest rates, a few different formulas that we can use. So if we're given the interest rates, the formula we need to use for simple interest is this one. And if we're given the flat rate of depreciation, where did I put that one? There.
So what are those ones that you've got down?
Sorry?
What are the ones that you've got down? Oh, how to find D and how to find N.
Yes. So these ones are if we're not talking about rates. These ones are if we are talking about interest rates. So some of them won't say, you might be given a recurrence relation and you'll be able to tell what it's going up or down by because it will be written in the recurrence relation. But if it's saying it's going up by 4.5% or going down by 6%, this is what we need to use. Does that make sense? We'll go through some examples as well. Yes. And that one's just the same as well.
Is it just the same formula?
Yep.
No, this one. Like for the last two.
Yes, it will be the same because it's still going down. So these ones have all got to do with rates. Or percentage rates even. Whereas these ones are if we're just told what we're going up or down by.
What's the difference between the second last one and the last one?
Nothing.
Oh, okay.
They are the same.
Will it be pretty obvious which?
Yep, we'll go through some questions right now and it will be, you'll be like, okay, that one or that one. All right, can I move down? Anyone still copying? No? Cool. All right, so let's have a look at a few questions and a few examples so we can work out which ones we need to use and how we're going to use them and what the different questions ask. Okay, so this one is saying the following recurrence relation can be used to model a simple interest investment. So they've given us the recursion relation. Okay, where Vn is the value of the investment after n years. So they're saying n represents how many years. It will usually be years, but sometimes it might be days, it might be months, but generally it will be years. Okay, what is the principal of the investment and how much is added to the investment each year? So the two things they're asking for is what is our principal? So what are we starting with? And what is our difference? What are we going up or down by? So pretty much all it's saying, can you read what this says? So our principal amount we know is the same as our V0. So for this one, our principal amount must be, yep, good, 300. And our difference must be, yep, 260.
So the principal's starting rate.
Yep, principal is the starting value. And the difference is what we're going up or down by. Yep.
Does it say for the difference that you're adding 260 or just put the number?
No, you won't need to because when we do the rule, you'll pick whether we're going up or whether we're going down. Okay, so write down the rule for the value of the investment after n years. And this is the question that I was talking about with that in terms of n. So we first need to be, okay, are we going up or are we going down? We're going up because this has got a plus. So we know we need to use the formula from our simple interest investments and loans. This isn't given to us in a rate. This is telling us what we're going up by. It gives us a number. So we're not going to use the interest rate formula. We're just going to use the first formula we've got there. So this is the VN V0 plus N times D. So that formula. And then two things we need to sub in. Our principal and our difference. So we've got Vn equals 300 plus N times 260. And just to make it look prettier, we're just going to fix that bit up.
Do you have to do the last bit?
You don't have to. No, it just makes it look, just be more mathematically correct. Any questions about what we've done here or why we've chosen that rule?
So ends years. So
Yes.
it says like however many years used.
Yep. But this is in terms of n, so we must have an n in
So
there.
if it says like after 8, it says like, we could put 8, like
Yep.
300 plus 8.
Yep, that's what we're just about to do in the next one. But this is really important that if it says n years, that you write it with both with the vn and the n at the end. If you don't put the n's in, or if you use a number, it won't be marked correct. Yes,
How did you choose that rule?
because we're going up, so we're obviously got to use one of the simple interest investments or loan. This isn't an interest rate. This is what we're going up or down by. So that's why we're using the first one, not the one that we wrote down. Any other questions? All right, let's go down a little bit. So the next question says, use a rule to find the value of the investment after 15 years. So that means use the rule we just found. So use this to find the value of the investment after 15 years. So this is our formula. And we need to sub in 15 to where our n's are. So we should have V15 equals 300 plus 260 times 15. We don't need to do anything with this bit. This is just telling us it's the 15th term, or the 15th year. That's all that bit at the front tells us. But we need to put it in there so that we're saying it's the 15th year. All right, so V15 was $4,200. Any questions about that one? Yep.
What if you don't put the 15 next to the V? Would you that not be anymore?
You would have to say that after 15 years. You have to put the 15 in there somewhere because you need to tell us what that number means.
Would
Yep.
you need to write out like after 15 years?
No, if you write that, that's fine because it's saying the 15th term is that. That's fine. Okay, the next one says use a rule to find when the value of the investment first exceeds $10,000. Okay, so we're going to use our rule again. The handy little rule. This time we don't know our n. We are trying to find n. So it's asking us how long. So when we are finding n, we don't have a value for n. So we can't sub anything in. So what we need to do is we need to put our 10,000 at the start of our equation. Leave n as n because that's what we're trying to find. We can't put a value in for it because otherwise we can't find it. And you're going to use solve on your calculator to solve for n. So you put that in. Anyone not know what I mean by solve? Good. All right. Put that into your solve and it comes up as n equals 37.31. So this is the actual value we get. So this is saying that after 37.31 years, that's when we get to $10,000. So the question is asking, when will it first exceed? We need to answer in full years Because when we're talking about interest, interest is calculated at the end of each year. So mathematically, it would reach 10,000 at 37.31 years. But because it's only calculated at the end of each year, it's only calculated at the end of 37, at the end of 38, at the end of 39. So it actually doesn't get calculated here. Does that make sense? So we've got to round up to the next number. No matter what this number is here, after the decimal point, we always round up, unless it is the exact number. So we would say that after 38 years,
Do you have to write it in a sentence?
You need to somehow show that it's 38 years.
38 years.
After 38 years, yeah. Any questions? So I've just got there, after 38 years, the investment will exceed $10,000. Any questions? Do we all understand why we've rounded this up?
Yep.
Yep,
What is that 37.001?
you round it up. All right, can I move down? Cool. All right, so let's have a look at this next one. Okay, Amy invests $3,000 in a simple interest investment, paying interest at the rate of 6.5% per year. Use a rule to find the value of the investment after 10 years. So this is different than the question we had before because we are told the interest rate, whereas before we were told what are we going up or down by. We were told that by the recurrence relation. So if we're told the interest rate, we need to use the second formula that we wrote down. So we need to use the one that looks like this. We need to use this formula. That's a good question, thank you. Thank you. All right, because it's investment, we know we're building money. That's why it's a plus here as well. Now this question just says, use a rule to find the value of the investment after 10 years. It doesn't say anything about in terms of N. So we don't have to write a rule with N in it. We can just sub all our values in straight away because it hasn't asked for a rule in terms of N. Make sense? Cool. All right. So we're looking for 10 years, so V10, our starting value is $3,000 plus our N, which is 10, the rate, which is 6.5, and by the starting value again.
In further, do we have to show like working this out? Like if we do it like, not that we have to, but.
No, if you want to do it all in your calculator, that's fine.
Oh, so you can literally just put that.
Yep, you can put that into your calculator.
Just
Yep.
write the answer.
Yep, that's fine.
So it says like 2
A
months.
question like that wouldn't be worth 2 marks. If it was, an explanation just at the end
Yeah.
after.
So you never
however
have
many
to
years.
actually do it by hand.
No, never.
You don't have to write that down. Can you like,
You probably do.
You don't have to write that down, but if it was, let's say, a 2-mark question and you got it completely wrong, writing this down, if you've written down that correct, that's a mark. Whereas if you didn't write that down, you got it incorrect, you get nothing.
so would you write down the rule or
For this one, because it's just asked for the investment after 10 years, you can just write it with the numbers in it. That's fine. And so V10 gives us $4,950. So just plug that straight into your calculator. You don't need to put that first bit in. Just start from there. Because that first bit's just telling us what term we're looking for.
Do you always have to do like the example with the sign?
Yes.
So will it always be like about money?
Yes.
Okay.
Yeah, because it's financial recursion that we're talking about.
Right.
Unfortunately. All right, any questions? Okay, let's move on to the next one. So, the following recurrence relation can be used to model the flat rate depreciation of office furniture. What is the initial value of the furniture and by how much does the furniture decrease in value each year? So we need our initial value and we need to know how much it is depreciating by. So our initial value is our V0, which is 12,000, and our depreciation is 1,200. Yep.
For that, for the initial value, can you just write VO?
Yeah, that's fine.
And D for depreciation or no?
Yeah, that should be fine. Yeah. All right, so write down the rule for the value of the investment after n years. So this is where we need to leave our n in the formula. We've been given the difference, how much we're going down by. So we don't need to use the one with the interest rates. We just need to use the one that's just the VO take n times d. Because we're going down, we're using the takeaway. So our V0 equals V0 take n times d. Oh, sorry, Vn, my mistake. Vn equals 12,000 take n times 1,200. And you can make that look pretty if you want.
But how come
How come it says flat rate?
Because it's linear.
how come in the formula it doesn't say VO? Was that a mistake?
In the on the sheet? Yeah, I made a mistake. I told you to write it in. Yep.
What was the mistake?
I forgot to write V0 at the start of that formula. Were you here for that when I made that mistake, Olga?
Yeah.
Yep. Okay, and then part C, use a rule to find the value of the investment after 6 years. So this means that our n is going to equal 6. So wherever there is an n, we're going to put in a 6. So we've got V6 equals 12,000, take 1,200 times 6. Put that into your calculator. So our V6 will equal $4,800.
Did you take away 6 times 12,000?
Yep, that'll work too.
Does it matter what way?
You must have this bit at the start though. But this bit, it doesn't matter whether it's n times d or d times n.
What do you mean by start?
The V0, you must have that number first, otherwise you'll get the wrong answer. Any questions? No? Are we good to move down? Yep, cool. Oh, too far. Is that too far? No, it wasn't, was it?
How is it double side?
Oh, it's okay. We're almost there. Promise you'll survive. Okay, so how long does it take for the furniture's value to decrease to 0? So we had our rule. What do we have as that rule? So that was our rule, and we're trying to find our n. So how long? Whenever it's talking about how long, that means we are finding n. So whatever, so then we need to put our 0 at the start because that's what it equals. That's like our answer. Put it in for solve in your calculator. And it will come up with n equals 10 exactly. So if it equals exactly, you can just use that number. So after 10 years.
Why isn't n equal 0?
Because it's asking us how long does it take.
Oh, okay.
Yep, it's not asking us after 0 years. So we've got to try and find how long it takes, which is our n. Any questions about that one? Okay, the next one says a photocopier in the office costs $6,000 when new. Its value depreciates at the flat rate of 17.5%. What is its value after 4 years? So we're talking about interest rate, we're talking about the value of it depreciating, so we need to use our interest rate depreciation formula. Which is our take.
Is it plus or take?
Take because it's depreciating.
But it's on the other thing I wrote plus. Is that supposed to be a negative? Oh no, because that was for that.
All good? It's depreciating, so it should be going down. Alright, and we want our n to be, oh, sorry, we maybe put in our 6,000 there. We want our n to be 4. Which ends up being $1,800. So after 4 years, the photocopier is worth $1,800. Any questions about that one, or why we use that formula? No? Okay, and the last question with 3 parts. We're not as enthusiastic as we were on Friday when we were trying to smash it out. Alright, a hairdryer in a salon was purchased for $850. The value of the hairdryer depreciates by 25 cents for every hour it is in use. Let Vn be the value of the hairdryer after n hours of use. So this is one where it changes and we're talking about n equals hours rather than years. So write down a rule to find the value of the hairdryer after n hours of use. So we've got our V0 is $850 because that's how much we bought it for. And we've got our difference as 0.25 because we're talking about 25 cents. If we're talking about cents, it's always easiest to keep it as a decimal rather than talk about 25 cents and just use the number 25, because then when we start talking about dollars, that's when it starts to get confusing. So if we're talking about cents, always use it as a decimal. We'll make it heaps easier for you. Okay, so then our rule. So we're going to be using, we're going down because it's depreciating. And we've got a value it's going down by. So we're using this rule.
Is that because you don't have a rate?
Yes. So our V0 is 850. Take away our n times 0.25. Okay, what is the value of the hairdryer after 50 hours of use? So this means our n equals 50. So we're going to use the rule we just found. Wherever we've got an n, we're going to sub in 50. V50. Oops. Times 50. So we've got V50 equals 850, take away 0.25 times 50. And so after 50 hours of use, it will be worth 800 and, oh, that's a funny looking $837.50. Any questions about that one? Can I move down? Oops. And the last one. Can I rub that bottom one off? Anyone still copying that bottom one? No? Okay, this last one's a little bit trickier. So on average, the salon will use a hairdryer for 17 hours each week. How many weeks will it take for the value of the hairdryer to halve? So a couple of things here. Usually we've been talking in hours, and the question is asking us about weeks. So because we're talking about hours, the answer we find is going to be in